Alright, so today is 5.4 sum and difference identities. So you'll see literally, pretty sure I copy pasted this right on your identity sheet. True? Yeah, true. Do you see that? Cool. Awesome. I might have rewrote it. I don't know. I forget if I rewrote it or if it's this exact thing. So sum and difference identities. What this means is you're adding, summing, or subtracting difference angles. So cosine of the addition of two angles, how can I rewrite that? Oh, cosine alpha, cosine beta, minus sine alpha, sine beta. So alpha is the first angle, beta is the second angle. So if you have something like cosine of 75 degrees, I'll be real, I have no idea what cosine 75 degrees is. But what we can do is we can rewrite it in terms of something I do know. So I could say cosine 30 times cosine 45, because minus sine 30 sine 45, because 30 plus 45 is 75, right? No? Yeah. Okay. I don't know what cosine 75 is, but what I can do is rewrite it as cosine of 30 plus 45, because that's a sum and addition of two angles. So how would I go about solving this? I would rewrite it as cosine 30 cosine 45 minus sine of 30 sine of 45. This is all what this is about. I give you a problem. Sine of some angle. You don't know that angle. The only angles you know are 0, 30, 45, 60, 90, and multiples of them. So what you have to do is a little Jenga. You got to fit it in. Okay, so I don't know cosine 75. But I could rewrite it as a sum of two angles. Okay, I could, well, let me think another one that would work. I could do 60, but I don't know 15, right? What? Because those are two that we know that add up to 75. I could pick 60, but I don't know the cosine sines of 15 degrees. If I pick other numbers, what if I did 120? You could do 60 and 60, or you could do 30 and 90. Right? So that one gives you two options to do. So these sum and difference identities are when I give you cosine, sine, tangent of an angle that you don't know. This is a trick play. I've told you 50 times. The only angles I can test you on are 0, 30, 45, 60, 90, and multiples of them. So you have to rewrite it in terms of 0, 30, 45, 60, 90, and multiples of them. Okay. So notice tangent's a little weird, right? Tan alpha plus tan beta over 1 minus tan alpha tan beta. So alpha, first angle, beta, second angle. I give you the identities. You just have to plug it in and go. The hardest part is figuring out which two angles to use that would actually add up to that angle that we're looking at. Okay, that's addition. What about subtraction? What if I have it's a good one. Trying to think of a good angle. Oh gosh. Trying to make it so it works. I know. A cosine of 15 degrees. How would you figure out cosine 15 degrees?
45.
Yeah, I could do cosine of 45 minus 30. So then you just plug in. Everywhere you see an alpha, you would plug in 45 degrees. Everywhere you see a beta, you plug in that 30. So it's a nice little example. Because I have no idea what cosine 15 is, but I know cosine 45, I know cosine 30. You can go through and figure it out that way. Yeah, we're going to do examples where we're solving, but I figure I would fully explain the identity before we go through and use it. Straight her hand up first, then I'll go to you. No? Yeah, okay, yeah.
For the adding one, does it matter which number you put first?
No. Because notice, for adding, here, the order, the multiplicative, commutative property of multiplication. Thanks, algebra. Commutative property of multiplication. 1 times 2, 2 times 1, same order. Order doesn't matter. That's why it doesn't matter here. Similarly, you're okay, sine of the first angle, sine of the second. Okay, as long as you keep wherever alpha is and the identity, if you put that first angle there, it should work. As long as you don't accidentally like, oh, hey, I put it in for alpha here and put it in for beta over there. Like, yeah, no, you got to be consistent. Okay.
For the difference one, would you put like -30 or just regular 30?
You would just put 30 because notice the negative sign is in the equation.
Yeah.
So the beta I'm looking at is 30. Good question. That was a good one. Okay, let's go through an example. Sine 75. I guess it was in my head. Well, since I don't make you memorize them, we can just do the example. Do you want to see the shortcut I was talking about? Yeah, let's do it. Okay, cool. Thanks. All right, so this is a shortcut, but since I give it to you, I guess it doesn't matter, but for your friends, if you're helping them with their math, they'll have to do this.
Is that all?
What? So this is for remembering what goes with what. If you have the addition of if you're taking sine of the addition of two angles, you have the addition in your like equation. If you're taking subtraction of the angles, you're using the sign with the subtraction in between. And this is like, why is this important? Because when we do cosine, sorry, my alphas, I need a little work. Because when you do cosine of the addition of two angles, it's actually subtraction in between them. And when you do cosine of the subtraction of two angles, it's an addition. I mean, is this useful? Yes. But also, you have your sheet, so whatever. There you go. Merry Hanukkah. I was going to say Merry Christmas, but Happy Hanukkah. Okay. All right, let's find the exact value of each of these. So this is sine 75. First, what I'd like to do is write this as an addition or difference of two angles. What pops out at you right away? Addition, 30 and 45. Okay, so we're on top of it. I did not mean to pick a number that was below. I guess that's why 75 was in my head, because I had it below here. 30 degrees plus 45. I can rewrite it as an addition of two angles. And then it's just plug in and solve. So I'm just going to plug it into the equation. So this is going to be sine 30 cosine 45 plus sine 45 cosine 30. Perfect. So where do I get these? Well, this is my alpha, this is my beta. In your equation, wherever you had alpha, you put 30. Wherever you had beta, you put 45. So the B looking thing is beta. I don't know if you guys seen it before. Maybe. Okay, it's a Greek letter. It's a Greek letter. If you know the Greek alphabet, alpha, beta, oh, it's the first two letters. Amazing. Yep. What?
No, it's like, is that,
We're not done yet. Don't worry.
when you're done, can I see the like table that you're on top?
Wait,
Oh,
this,
yeah.
This is the equation that you wrote on top.
You know what? I'll just go back here for a sec while you can copy this down. Okay, so I filled in all of my angles, and now instead of saying sine 30, I'm going to plug in the value. What is sine of 30? 1/2. Yeah, put that down. And then cosine 45 is 2 over 2. So instead of saying sine 30, I put a half. What's wrong, dude?
I'm having trouble drawing the.
I'll give you like
it
5 more seconds to write this.
very similar to
Okay, Bradley.
For the set identities for cosine, when it's like the second option, like you subtract sine and sine or whatever they're called. How do you know which one should go first for that? Like, does that matter?
No. I mean, so with cosine, do you mean like which one should you write first, sine alpha or sine beta?
Like, when you put it in the parentheses and let's say like it was 30 and 45, does it matter which one I put is? Like,
Well,
can I do 45 first or 30?
So with the difference, like you need it to actually be the number. So if I was, since I'm doing sine of 75 degrees and I'm adding alpha plus beta, I could take 45 plus 30 or 30 plus 45. But if I'm doing the difference identity, those are two different numbers, right? If I take 30 minus 45 and 45 minus 30, those are two different numbers. So then it does matter.
But for the sum identities,
For the sum, it wouldn't matter because the commutative property of addition. So if I took 30 plus 45, it's the same as 45 plus 30. Because either way, it adds up to the same number, but the difference identities, like you actually have to make it equal the number I want it to be. What am I trying to say here? Yeah, so here I could also write this as like sine of 45 and put a 30 here and a 30 here and a 45, and I'll get the exact same answers because it's a sum. Because if I take 30 plus 45, it's the same as 45 plus 30, so that's why it doesn't matter. But if I take the difference, like up here, if I was trying to do cosine 15 and I took 30 minus 15, that's a whole different number. I mean, the even odd identity for cosine, it wouldn't matter, but like for sine it would. Okay, let's go and let's finish out this problem. Okay, so we all wrote the stuff on the top. So sine of 30 degrees we said was 1/2. Cosine 45 degrees, root 2 over 2. Adding sine of 45, root 2 over 2. And cosine of 30 degrees. Cosine 30, root 3 over 2. Okay, so I have that. Let's go ahead and let's simplify this a little bit. So I have root 2 over 4 plus root 6 over 4. So this is just going to be root 2 plus root 6 all over 4. That is the exact answer. It says exact value. So whenever it says exact value, if you have a pi, you leave it in terms of pi. You have a root, you leave it in the root. Exact value means you don't round. You don't want a decimal place. Okay. So I'll give you a sec. Think about what bothers you, what troubles you. If you're done with this one, start working on the next one. Think to yourself, like what two angles would add up to this 11 pi over 12? So literally, but what you do know, 0, 30, 45, 60, 90, and all the multiples of 0, 30, 60, 45, 90. So you might have to use a multiple of them.
Can you leave it in radians?
You should leave it in radians. I mean, if it helps you to convert to degrees to like figure out what it should be. How many degrees? 165? So you could figure out in terms of degrees, and then we should leave it in radians. If I give you a problem in radians, like ideally if the answer should be in radians, you should have it in radians. That was really big. If I'm looking for an angle and I give you something in radians, I'm expecting radians back. Cool. It's kind of like if you're in America and I give you like money for something, like I give you dollars, I'm expecting some dollars back, not like euros. Like why? Yeah.
Can you solve it in degrees
Well, here the answer is not going to be in radians. It's going to be in like some numbers and a root. So 165. Let's see what angles. 90 and 75. That doesn't help me. How about like multiples, like 120 and
pi over 4 and 2 pi over 2. 45.
Yeah, so I could do 120 degrees and 45. So this is pi over 4. And let's see, 120 is going to be 2 pi over 3. So if I add these together, it should equal 11 pi over 12. Let's make sure this is true. Cool. So I have the right angles. I'm sure there's another one that could work. Maybe 135. Yeah, 135 and 30. That would also work. That would be another example. Yeah.
What's 130?
3 pi over 4. So this is another example that would work, is 135 and 30 degrees, because this is a multiple of 45. That's another example that would work for us. You know, that would be fine. Just to show you, like, there's more than one way to do it. Sweet. More than one right addition. Okay, so we're going to use 2 pi over 3 and pi over 4, or 120 and 45. So I know that I can rewrite this as tangent of 2 pi over 3 plus pi over 4. So this is going to be tangent of alpha plus tangent of beta all over 1 minus tan alpha times tan beta. You could like, instead of putting like writing in radians, you could write it in degrees, but you also need to be cognizant of the fact that you need to get comfortable with radians. If you're going to take calculus ever, period, you have to be like fluent in radians. You have to know radians. You have to be comfortable with it. So if you're uncomfortable, let's work on getting cozy with it. Okay. So what's tangent of pi over 4? Tangent of 45 is 1. It's literally 1. Okay, that helps us a little bit. And then tangent of 2 pi over 3. Negative root 3. Just to make sure we understand where that comes from. So if this is 2 pi over 3, that means that angle right there is pi over 3, which is a 60-degree angle. Right? Pi over 3 is 60 degrees. 60, so across from 60, root 3 over 2, across from 30, 1/2. So if I'm taking tangent of 60, tangent opposite over adjacent, opposite over adjacent, root 3 over 2, divide by half. The 2's cancel out and you get root 3. Except, all students take calculus, tangent is negative in the second quadrant, and that's why Shane said negative root 3. So this is this little triangle thing I'm doing right now. Like, you don't need it on your paper. But I'm wanting to show you, so that way minimize people that are lost. And then it's negative because we're in the second quadrant. All students take calculus, tangent's negative in second quadrant. All right, yes?
How did you get
So pi over 4 is 45 degrees. Tangent is sine over cosine. 45 degrees, sine and cosine are the same thing. Root 2 over 2 divided by root 2 over 2. So 45 degrees, I have an isosceles triangle. 45, 45, they're the same exact value. So if I'm taking tangent is opposite over adjacent, it's literally the same number on top and bottom, so that's just equal to 1. So for us, it's literally root 2 over 2 over root 2 over 2. That's the same number, so it's just 1. All right, perfecto. Okay, so now I gotta simplify this a little bit. Ideally, we want no radicals on bottom. So if I multiply by 1, it's just the same thing. Maybe that'll help us a little bit. So I have negative root 3 plus 1 on top, 1 minus root 3 on bottom. How could I get rid of the radical on bottom? But I have 1 minus.
1 minus radical.
1 plus, and we call it starts with a C.
Reciprocal.
Close. Multiplying by the
No.
C-O-N-J-U. Conjugate. A conjugate. What is a conjugate?
Just the different.
It's the other half of the difference of sum. The difference of squares. So if I multiply by 1 plus root 3 over 1 plus root 3, beautiful. Sorry it's so colorful. I did not mean to do that. I thought that was the same color. Whatever. Okay, I'm multiplying by the conjugate. That way I won't have a root on the bottom. By multiplying by the conjugate, making it so it's a difference of squares, the whole like O and I of FOIL, remember the first, outer, inner, last, the O and the I go away. And then you literally just have the first and the last. Yeah?
So the other, I don't
Ah.
feel like you want it to have like this stuff.
Uh-huh.
Why can't you just do on the bottom? Negative rad 3. Hey.
Hold on. Multiply by negative rad 3.
No, not multiply, but like, just write it negative rad 3 plus 1, and then it's the same as the top. Do that. Just like rearranging it, you keep the same.
No, you can't because
It's
actually supposed to be 1 plus rad and then it's like, is it because you were subtracting a negative?
Oh, yeah, there should be another negative sign right there. My bad. Because it's negative.
So it'll be plus.
Well, then wouldn't you have to multiply by negative?
Yeah. Sorry.
Wait, why did you say that?
Because this guy right here is negative root 3. And subtracting a negative, same thing as adding a positive. Yeah. So it turns into plus. So we multiply by the conjugate, which is 1 minus root 3. And this is why it's important to show your work. Because missing a little negative happens to everybody. This is also why I use pencil in your notes. Hey. Mostly, yeah, for me. Okay, so if I multiply these two out right here, I'll get 1 plus root 3 squared. Well, root 3 squared just turns into 3. That's on the bottom. And the top I get, let's see, negative root 3, what?
Isn't it negative root 3 squared? So you're going to multiply by negative root 3?
Negative, yeah, it should be minus 3.
No, on the right side.
What?
Because you're multiplying the positive with the negative on the right side.
Where are you looking?
You're rationalizing and multiplying them.
Maybe 1 minus 3, right?
Yeah, so it's 1 minus 3 on bottom. Yeah. Let me rewrite this so it looks a little neater. Okay, so negative root 3. Let's see, the bottom is 1 minus 3. Then I have plus 1, plus 3, minus root 3. So this just turns into 4 minus 2 root 3 over 2, negative 2. But I can simplify this out. I have 4 over negative 2 minus 2 root 3. I could actually, I want to do it this way. That way you can see the negatives cancel out. This turns into negative 2 plus root 3. Yeah. So the hardest part has nothing to do with identities. It's the algebra, it's making sure you don't drop your negatives, making sure you multiply your conjugates correctly. Okay. Questions? Yeah? No? Okay. So example 2. Yeah, this lesson's only front back 1 page, but it takes a while. Fun. So example 2, an alternating current I in amps in a certain circuit can be found after t seconds using I equals 4 times sine 255t. So what we're going to do first, rewrite the formula in terms of a sum of 2 angle measurements. So what 2 angles that we know that are either 0, 30, 45, 60, 90 or multiples? What adds up to 255? So I just want to rewrite this as a sum. sine of what two things added times t. And it says a sum, so I want to be adding, not subtracting. 180 plus 75, no, it doesn't work.
I before it's like obviously.
So I could say exactly 210 plus 45. And the only reason I'm writing it in degrees is because it gave it to us in degrees. If they would have wrote it in radians, I would have wrote it in radians. Cool. Okay, so rewrite it in terms of the sum of two angle measurements. We did. Now use a sum identity to find the exact current after 1 second. Okay, so after 1 second means I'm plugging in t equals 1. So I have I equals 4 times, let's see, sine of the sum of sine. The sum identity is going to be sine of 210 degrees times cosine 45 degrees plus cosine 210 degrees times sine of 45. And then don't forget to multiply by your t, which is just 1. So the 1 we can just ignore.
Is there one sine in the first one to be 2 sine and then cosine to be 2 sine in the second one?
Because that's the alpha. If you look in your identity sheet, it goes sine alpha cosine beta plus cosine alpha sine beta. I don't know if this will help. Here's my alpha, so I plug it in at these points. Here's my beta, so I plug it in at these points. I feel like color coding may help, maybe not. Okay, now we just have to actually figure out what those values are. So I have 4 times sine of 210 degrees. 210 is, let's see, 30 degrees more than 180. So I'm taking sine of 30 degrees. Well, sine of 30 degrees is a half, but I'm in the third quadrant. That's why it's going to be negative 1/2. Cosine 45, that's just root 2 over 2. So sine of 210, cosine 210, so remember it's like right here. This is 210 degrees, which means you're looking at what? Square root 3 over 2, yeah. So this is 30 degrees.
Why isn't root 2 over 2 negative?
Because it's cosine 45. 45 degrees in the first quadrant.
Why isn't it? Oh,
We're all good. Okay, so I just drew the little triangle that's right here. Do you guys see where I'm coloring? Maybe not. This triangle right here, that's, oh my god, load. That's what is right here. Okay, and I even put the correct positive negative so that way we're not so confused. So that's 210 degrees. Sine is opposite over hypotenuse, so that's just negative 1/2 over 1, which is negative 1/2. And then plus cosine 210. So cosine of 210 degrees is going to be negative root 3 over 2 times sine of 45, which is just root 2 over 2. So that's going to be equal to 4 times negative root 2 over 4 minus root 6 over 4 distributed out. Negative 4 root 2 over 4 minus 4 root 6 over 4. The 4's cancel out. I'm left with negative root 2 minus root 6. Perfect. So far, what we've been doing is we've been expanding, right? So I give you a certain angle, you have to rewrite it as a sum or a difference. So we've been taking a single angle, expanding it out. What if I have you do the opposite and condense it? This next example, find the value of tan 78 minus tan of 18 all over 1 plus tan of 78 tan of 18. Like, what the hell? You don't know 18 degrees. You don't know 78 degrees. But what you do know is, wait, this is, I can rewrite this as tangent of 78 minus 18. So what you can do is you can go the opposite direction. I'm going to pick a different color. So I can give you a problem like this, and you have to go the opposite direction. So that means you're going to go and condense it. So wait, I can rewrite this as tangent of 78 degrees minus 18. So it's just going to be the same thing as tangent of, I think Sarah said it, of 60 degrees. Then wait, what is tan of 60 degrees? Root 3. Awesome. So instead of having to go through all the bull honky of like this nastiness of 78 and 18 degrees, you can just go opposite. Condense it. Yes?
Why would they be plus 18 if it's like minus?
So the difference identity for tangent is tan alpha minus tan beta. So that's tan of alpha minus beta. If you look at your identity sheet.
But it's not negative, it's minus.
Right. So let me come up here. Notice tan of alpha minus tan of beta is literally your angles subtracted.
Yeah.
Oh my god. So tan alpha minus tan beta is just going to be alpha minus beta. Cool. So that was a nice problem. Just condense it, go the opposite way. Let's see if we can simplify this. Example 4. So I have sine times cosine and cosine times sine. So that only happens with the sum and difference identity of sine. Right? So this is either going to be sine of alpha plus beta, or it could be sine of alpha minus beta. So we look at our equation sheet. Which one does this line up with? The plus, right? Plus here, plus there, cool. So this is literally going to be sine of pi over 3 plus pi over 4. No, because it doesn't say, well,
Because converting it back,
you'd have a number,
you end up with 7 pi over 12, which doesn't make any
which is simplifying. It doesn't say solve, it says simplify. So simplify, we always want to go from like more terms to less. So number 3 said find the exact value. Number 4 just says simplify. We're not trying to actually solve it, just simplify. So this is equal to sine of 4 pi over 12 plus 3 pi over 12. So that just turns into sine of 7 pi over 12. All right. Have done with the lesson. Woo. Okay, that's fine. Don't have to be excited. It's good. See some people still writing, so I'll wait a sec. And this is why we covered 4.6. Even though I barely included it on your test, we had to make sure you knew it. Otherwise, this would be really hard, and you are expected to know how to do this. Okay, cool. Do you need more time to write down? Okay, cool, let's go. All right, so example 5. Write cosine of arc sine root 3 over 2 plus arc cosine x as an algebraic expression of x that does not involve trig functions. Wow, this is a rough one. Okay, so first thing I want to do is I see I'm taking cosine of a sum. So just remember cosine of alpha plus, oh, that was not a good beta. This is your beta, this is your alpha. Because remember, arc, cosine, arc, sine, they're your sine and cosine inverses. They literally will find you a measure of an angle. And throw back to 4.6. If I had cosine of arc cos of pi, What happens when I take cosine of arc cosine? Yeah, they cancel, and I'll just be left with pi. Okay, that's really all the review and like prep you need, because you can solve this problem. You can, 100%. All right, so let's write it as an algebraic expression of x that does not involve trig functions. So the first thing I'm going to do is rewrite this as the other half of the sum identity of cosine. So cosine alpha, so that's arc sine root 3 over 2. Cosine arc cosine x. Oh my god, I can't even read it. Arc. I'm following the identity. Remember, cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. I'm just plugging in. Literally, this is my alpha, this is my beta. I'm just plugging into the identity.
What's the cosine in between them?
What?
Like, what's the why is there a cosine in between arc sine and
Just mark up. And you add them, right?
So since this is an addition, a sum of cosine, it's a difference.
Oh, okay.
So look at your identity sheet. The identity sheet shows you plus and minus. So your identity sheet says cosine alpha, cosine beta, minus sine alpha, sine beta. That's all I did. I said, here's what alpha is, here's what beta is. Plug those in to your little identity. Let's start with the easiest one first, all right? Let's start with the easiest two. Let's do that first. Okay, cosine, arc cosine, guess what? This just goes to x. Sine, arc sine, this just goes to root 3 over 2. Those are the easiest two ones to do. So, try not to go too fast. And pause for a sec. Is it clear what I did with this like maroonish brown color? Cosine of arc cosine of x. Wait, I'm saying for what angle is cosine x, and then I'm taking that same angle, cosine of that angle. Oh, it's literally just going to be x. Cosine and cosine inverse, cosine and arc cosine, they cancel each other out. Huh? The sum identity of cosine. And so if you have cosine of alpha plus beta, you're doing cosine alpha cosine beta minus sine alpha sine beta. Cool. All right, so let's do the next one. Let's take this guy right here. Okay, right here. So this whole arc sine, like literally what it's saying is for what angle is sine equal to root 3 over 2? For what angle is sine equal to root 3 over 2? So we know that's pi over 3, which is 60 degrees. Okay, so then if I replace this whole thing with 60 degrees, right, I solved. I know what arc sine root 3 over 2 is. It's 60 degrees. Plug that in. Now I want to know, okay, what is cosine of 60 degrees? It's equal to 1/2. Okay, so that's what I bring over here. So I have 1/2 times x. Maybe I should move that down. Am I? Yeah, sorry. Don't get mad at me. I'm just moving it. Okay. So this is 1/2 times x minus root 3 over 2. So we have most of these. 3 of the 4 ones we have done. The hardest one is what's left. I'm taking sine of arc cosine of x. Whew.
Wait, how did you, for the purposes, for what angle is sine of x equal?
Root 3 over 2?
Yeah, can you go?
Yes. So root 3 over 2 tells me 30, 60, 90 triangle. 60 across from root 3 over 2, 30 across from 1/2. So I'm looking for which angle is opposite over hypotenuse, root 3 over 2. Wait, opposite over hypotenuse would be this angle. For sine, where is sine equal to root 3 over 2? 60 degrees. Perfect. Okay. Scroll over a little. So this is the last one. A little hard. Okay. So let's draw a triangle over here. And I know cosine of this angle right here, this angle x. Hold on. I know cosine of my angle is adjacent over hypotenuse. It's going to be x over 1, right? Because arc cosine x, it's saying for what angle is cosine equal to x? Well, this angle right here that I drew, this theta. But then I'm trying to take sine of the same angle. But sine is opposite over hypotenuse. I need to find the opposite side. How would I go about finding the opposite side? Pythagorean theorem. So I have 1 squared equals x squared. I'm just going to call it b squared because this is the side I'm looking at. So I have 1 minus x squared is equal to b squared. So wait, this side right here is going to be square root of 1 minus x squared. So if I'm trying to find sine of this same angle, it's going to be opposite 1 minus root of 1 minus x squared over 1. So I was just wanting the side length. Yeah, I just want the side length.
That's what we're finding sine of, is that the...
So this is, I want to take sine of this angle. Sine is opposite over hypotenuse. Opposite 1 over square root of 1 minus x squared over 1. So I'm going to come down here and I'm going to write it. So this is going to be equal to, let's see, x over 2 minus root 3 times root 1 minus x squared all over 2. So that's the same thing as x over 2 minus, okay, so when you have 2 roots, you can multiply them, right? Multiply whatever's underneath them. So it'd be square root of 3 times 1 minus x squared all over 2. We're getting closer. We're almost there. Yep, boxed it. That's the answer. Done. So I'm gonna walk you through from this step to the end as soon as like people aren't frantically scrambling and writing. So. Uh, 100%. There's gonna be a question like this on your test. But remember, your quiz is only 5-1 and type 3. But there will be a question just like this on your test. I don't know if you want to star that. Cool. I'll also give you, you know that 5-1 and 5-3 study guide I gave you? I'm going to give you one for 5-4 and 5-5. They won't be homework. It's just good extra practice. I think we'll actually have a whole day where we can just like work on it again. Okay, so we see where we got the half. We see where we got the x, we see where we got the root 3, see where we got this blue one. So what I did was, okay, 1 times x over 2, we're good with that part. Then I have root 3 times root 1 minus x squared all over 2. And I have to, when you have 2 roots being multiplied, you can multiply what's inside them. So then I have all 3 times 1 minus x squared distributed out. So I have 3 minus 3 squared all over 2. Because they both have a common denominator, so I'm just write them over the same denominator. Okay, good questions over this one. It's just going to take practice, honestly. So. So I know you guys have the math ability to do it. It's just like it's new, right? It's new, so it's hard. Okay, and then the next two aren't too bad. They're actually relatively simple. Are you guys feeling prepared for the quiz? Yeah, for the quiz that's on Thursday. Do we have more questions over it? So I was thinking is we take like 2 more minutes, do example 6 and 7, and then I can have like 10 minutes for you guys to like ask questions. And then we can just finish this last problem after the quiz next class. Yeah? That way you guys can have some more like practice time with me. Okay, because they're very short. Verify cosine negative theta equals cosine of theta. So verify means prove it. And this is why I went through like some verifying with you. So it's not exactly new. At the end, I want the left side to equal cosine of theta.
Wait, is this like a proof?
Yep.
But it's
We're solving it, right? It's not like
We're proving it. It's verifying. We did
Do we have to,
the
like write like what we're using, like an identity? Like,
no. We're just proving the left side equals the right side. So first what I'm going to say, okay, so cosine negative theta is going to be cosine of 0 minus theta. Well, if I have negative theta, that's the same thing as 0 minus theta. And if I write it as a difference, then I can use the difference identity. Hey, no, yeah, yeah. Okay, there's a problem like this on your test. Awesome. Maybe I should not tell you that. Cosine 0 degrees times cosine theta plus sine of 0 degrees sine of theta. Oops, it's supposed to be 0. We know what is sine of 0 degrees? 0. So wait, 0 times anything, that whole side goes away. What's cosine of 0? 1. So cosine, so 1 times cosine theta plus 0 times sine theta. That's just going to be cosine theta, because that side goes away. Hey, QED, donezo. See, told you to take long. Ready for the next part? Yep. Okay. I don't think you guys understand like how well you are doing. Like I see your faces and I see you're like full of doubt and questions, but that's fine. Because you're not giving up, alright? So like I applaud you, you're doing great. Just keep in mind. Keep that in mind. This is not an easy class. It's difficult, but you're doing it. Just need pep talk. Pep talk yourself. Alright, verify, aka prove. What I want to do at the end, I want to say the left side is equal to the right side. It should equal sine theta. Ooh, I got a difference, right? A cosine difference identity. So it'll just be cosine theta times cosine pi over 2. Let's see, cosine, so it's plus sine theta sine pi over 2. So it's going to be cosine theta times 0. No, because this is alpha minus beta. So the minus is part of it.
I ended up with negative,
You shouldn't, because...
Oh, it's plus.
Woohoo! Check it.
If it were not to equal, what would you write?
If it was, it will equal. Because it says verify. I'm not going to give you a problem where it doesn't work. That's so mean. Verify that these things aren't real are real. No, that's so mean. Because the reason to do this is showing you, like, know how to, like, apply. Okay, yeah. So we'll stop here. That way we have a solid, like, 13 minutes. We're going to just go over more problems for your quiz.